Hello class, welcome to our second portion of section 3.3 dealing with the unit circle and dealing with circular functions. The first example we're going to look at is specific to the idea of the unit circle, but you don't have to know anything specific about the unit circle to be successful on this question. What you need to know is what x, y, and r, okay, are being in this question. So for this ordered pair, this should go all the way back to the beginning of the semester when we did here's x, here's y, find r. The nice thing about the unit circle is that r is 1 because the radius of this whole circle is 1. So x would be negative 15 over 7, y would be 8 over 7, or excuse me, 15 over 17, y is 8 over 17, and r is always 1 for the unit circle. And then sine is just y over r, so that would be the y value, 8 over 17 over 1, which is just 8 over 17, which you'll notice is the y value of the ordered pair. Cosine similarly is just negative 15 over 17. Tangent, what's going to happen is the denominators will cancel out, so you do the y value divided by the x value, and it'll just be the numerators essentially. And that's the basic idea of how the unit circle actually works. The nice thing about questions like this is the unit circle premise helps, but you still have to understand how x, y, and r operate in these scenarios. I didn't find the other three trig functions, but it would just be those things reciprocal. Okay, the rest of the questions we're going to look at are solving kind of around the circle. The key is what units do you need? So if it's 0 to 360, make sure the mode of your calculator is in degrees. And if they say cosine of x equals 0.53, we've done this before, do cosine inverse, and you find that it's about 58. And then the second answer is in quadrant 4, and to find an answer in quadrant 4, it's 360 minus the reference angle, and you get 302. But your mode has to be in degrees to get that answer. Next one is cotangent. Remember, if you have cotangent, you need to do its reciprocal. So you need tangent, and that's 1 divided by 1.75. Tan inverse of that, you get just under 30, 29.74. That's also the reference angle because it's in quadrant 1. The second answer is in quadrant 3 because tangent's positive in 1 and 3. And to find the answer in quadrant 3, it's always 180 plus the reference angle, and you get 209. So you got the 180 plus the reference angle of 29, and that will give you your answer of 209.74. The next one says you want the answers from 0 to 2 pi. Now, what I'm going to go through is if you want to have your calculator in radian format to find the answer. You do have an option that you could just work in degrees, like this question, or this question, and you could just do the question in degrees, but when you get to the last moment, instead of your degrees, you would have to convert it from degrees to radians, which would be times pi over 180. That idea will work in these scenarios, but you can kind of cut out the middleman if you understand how radians work well. So if I want to be in radians, I have to change my mode of my calculator to radians. And then do cosine inverse of 0.42, and in radians, it should be just over 1 radian, 1.137. That's one of the answers, and if you think about it in degree format, that would be the reference angle. Same idea here for radians. The second answer for cosine is in quadrant 4. Well, normally in quadrant 4, we take 360 minus the reference angle to find the answer. Well, I'm in radians, and 360 degrees is the same as 2 pi radians. So that would be 2 pi minus the reference angle, and you get just over 5 as your final answer for that question. That would be how you work with it in radian format to start with. And the key is knowing that 180 is pi, 2 pi is 360, and the same add subtract ideas apply from what you learned with degrees. The next one is cosecant. The rules still apply, you still flip it. So sine would be its reciprocal, 1 divided by 1.25. I do the inverse in radian format, and I get 0.927. That's also the reference angle. I found the answer in quadrant 1. Sine is also positive in quadrant 2. And to find the answer normally in quadrant 2, you would take 180 degrees minus the reference. Well, I'm in radian format, so instead of 180 degrees, I do pi minus the reference angle. And then I get 2.214. I know this is a challenge because radians is a new idea. Think of it like a different language or a different currency. Okay, they go with, and there's some relationship with degrees, and there's a conversion between the two. But I know it's new, and so the reasoning itself might be a little bit off for the time being, but that's how it would work. And then don't forget, you can also work with this question in degrees, and then at the last moment, you could multiply by pi over 180 to find the answer in radian format. So the key with your calculator to get questions right, especially for a test, is to make sure you're in the correct mode based on the interval given to you, and that should be helpful to you as you go through these questions. Have a good day, everybody.